Recorded live. Good morning, good evening, wherever you may be, across the nation or around the world. Once again, you are listening to the VMware Community Roundtable Podcast. This is podcast number 500. Today is March 12th, 2020, going down in history as number 500. With me today, I have my regular co-host, Ishmail. Ishmail, how's it going?
Going great.
Right. Special
Congratulations on the 500th podcast.
500, but really wasn't me. It was John Troyer, and today we are going to have special guest John Troyer join us on the call.
Wow.
So we're super excited about that because John hasn't been back on the podcast since like 279. So he did over half of all the ones and got it started. So we're going to talk to John Troyer. Also on the show, we're going to talk to Andrei Warkentin. Today's a special show as well because we're going to finally talk about ARM and ESXi on ARM and a Fling that's going to be on Raspberry Pi 4, the 4 gigabyte model. So that's a super exciting topic today. I can't wait to take everybody through what VMware is doing around in ARM. That's going to be the show topic today, and we're going to officially talk about when we might see an official code base that we can actually run on a Raspberry Pi 4. So we're going to get to that. Before we do that, though, Ishmael, what's the color of the bay today?
The color of the bay is a beautiful turquoise, a little bit of gray. We got some, you guys can't see it, but we have cloudless skies. Birds are chirping. It's beautiful here in Palo Alto today, guys.
It is. It's the Indian summer for sure. We're going to, it's just been beautiful weather. Yep. It's like mid-60s, 65. So for you guys out there, Corey Romero in Utah and Tony Foster out there in Kansas City somewhere, enjoy that snow. I know it's been cold and snow. So we'll pop over to Corey Romero. Corey, how's it going? I know the vExpert apps, you guys are voting. I know the weather is still cold up there. Why don't you tell us a little bit about what's happening with vExpert apps?
Yeah, absolutely. Hey, thanks, Eric. Hey, so we are currently still in the process of doing the applications. We're almost done. We expect to have the award announcements within the next 2 weeks. As far as Utah goes, it snowed this morning pretty good, and then the skies cleared up, and it's nice and sunny and warm-ish. The difference between the weather, the cold weather, 60 here or even 30 here versus 30 in California, right? California has to tend to have a little bit of wind. When the temperature drops down here, we don't have that wind, so 30 is actually pretty comfortable. It sounds a little weird saying that, but it is.
Yes, but your brain has to.
Expert. What's that?
That's what your brain has to tell you. Hey, I don't mind that it's snowing and cold. It's really not that bad. I got that.
Right.
I got that.
Yeah, so as far as the vExpert program goes, let me go over just a little bit more there, if you don't mind. So we're going to wrap up applications and awards within the next 2 weeks, and then a week afterwards, we're going to kick off some sub-programs. So we're going to kick off voting all at the same time. Sorry, applications all at the same time for vExpert Pro, NSX, vSAN, Cloud Management, Security, HCX, and finally, end-user computing. So we're going to have all of the sub-programs. So I'm really excited about that. I will send out mail to all of the vExperts, and once those applications open up, and we'll get going on those as soon as possible.
Yeah, fantastic. And John Troyer is going to be on the call too, and it's our 500th, but also it's great to see the vExpert program grow to the point where we can have these sub-programs because John will remind us that the vExpert program, John and I built that together. John, launched it, and it really was about, being able to treat people special and to give them access to briefings and to really help them be really great bloggers. And John was always on the notion of keeping it small. And I was, as a marketing director, always trying to make it big to compete against Microsoft and their MVP program. So we tussled back and forth between big and small. And I think the sub-programs are a perfect blend of that, which is the sub-programs are under, 200 people. It's like under 100 people for a sub-program. You get care and feeding, hand-holding, branded items, all the good stuff of a small program that John always liked to do, and yet we still have it under the vExpert umbrella, which is the big program. So we're going to have, how many of those programs? 7 programs now? And are there,
we've got 7 sub-programs,
on each of the programs? Yeah.
Yep, BU leads on all of them, so which is full support, which is great.
That's great. So applications are ending up on the sub-program, so great news there. And if you've got your vExpert app in, you should be hearing from us shortly. So awesome there. Thanks a lot, Corey.
Yeah, absolutely. Thank you.
All right, moving on to our first special guest. John Troyer is in the house, on the call. John, how's it going?
Hey now. Hey, Eric. Hey, everybody. Things are going great. Really glad to be here. Thank you for inviting me.
Well, thanks for coming back. I think it has been since the original, when you left VMware, around 280 podcasts or so that you had done them. And I got to say that it's crazy how these things keep ticking off week after week. And I got to thank you for developing a model with the original podcast that really is a great way to do podcasts, which you invented the idea of just doing a live stream before live stream actually existed, right? You found this thing called TalkShoe, and you just started doing them every Wednesday. It wasn't about the quality; it was just about the connection with the people on a regular scheduled event. I mean, is that kind of the way you kind of looked at that? Why don't you take us through how you ended up starting this thing to begin with?
Sure. I mean, it was the early days of, what is early, right? Was it 1999? No, it was, towards the 2008-9, right? And
right.
we wanted to get to know, we already had moderators on the forums and things like that. We had user groups going on, but it's not like we saw each other that often. And we wanted to start some sort of a communication and, get to know people. And so the first couple actually were pre-recorded. And I took some of the moderators and we just kind of had a conversation. My original idea was, let's do like Washington Week in Review, and like everybody will like be a reporter and they'll cover one story for the week. Well, that lasted about 0 shows, and
right.
It quickly turned into just kind of a conversation, and with guests. And the live thing after it, the other thing, both with the experts and I think everything we did was start simple and try a lot of things and iterate, right? Eric, you and I over the years, we launched, we tried things, we
sure.
started, we had events, we started parties, we did different blogs and things, and
right.
Some of them worked, some of them didn't, and you don't remember the ones that we didn't go forward with because they were trials, and the things that seemed to resonate, we did. And so very quickly with this talk show stuff and with the chat, it's kind of funny, we're still on the same platform. It took off, and once we were live, right, and it became like a campfire, right, where everybody could join. And sure, it might the audience was a few thousand people maybe, but then the live audience was maybe a few dozen ish, but like it was a gathering place, and it was a rhythm, and people would stop their day for this. So and people still do. So it was pretty cool.
Yeah, it is good. And you know what? I still get reminded of the failures because being at VMware for 10 or 12 or 13 years now, I get new people that come in and go, we want to try this. And I'm like, yeah, we tried that. It didn't work. Like, I got to get reminded of all the ones we did. But you're right. We do lots of stuff, and we fail at a lot of stuff. But the ones that hang in there are the ones that end up being successful because they are successful. But I would say that you hit on a great thing, and when you handed it off to me when you left VMware, you had said, like, look, it's about that regular schedule, right? That every Wednesday we don't record it, we don't spend a lot of time massaging and editing, and it's just live. But then by the end of this session, at 1:00 when we do the barbecue report at the end, we're done. We don't go back and touch it. We don't have to spend an hour. And that's the way you can actually keep having them week after week, right? Is that keep it simple.
Yeah. I've been involved in many podcasts since this one. And most of them are edited, and I got to say the work is another 10x. Now, you guys do video and all sorts of stuff like that, and that's a lot more work as well. We tried to get that going 10 years ago. But I think for people in the audience, right, there is, people in the chat are like fail fast. Yeah, even in your own work, right, you try something to see if it works first in the lab or whatever. You don't just roll it out in the production. And then just the immediacy, right? That talking to your colleagues in person or live is much things, email or blog posts or whatever, that is an asynchronous method of communication. It's nice to get everybody together, and it seems to work. Yeah, and I'll echo you, Eric. We couldn't have done it. You can't do it every week with scheduling guests and guests who cancel and all sorts of stuff. Anytime you can do something that just has one take is pretty good.
Yeah, it is good. Ishmael had a question.
Oh, no, it's that comment. That was you kind of talking about the live versus the pre-recorded, and that was one of the things that kind of caught me when I first started here at VMware, that when I'm listening to your podcast, it's a very real conversation, right? You're not going back and having to worry about edits and scripts and things like that. It is what it is.
Yeah.
Put it out
natural
there.
Feel,
yeah,
right? It's just people talking.
Exactly.
Yeah, and I think John did that. A few more minutes on this topic before we get to Raspberry Pis and ARM with our real guest here. John, when did you hit on maybe having a co-host? Because I have Ishmail here. At some point, did you just decide I need somebody else? What was the idea of co-hosts, and do you remember any of the famous ones? Or who you like?
I did it myself for quite a while, and then I eventually one has to travel or something, right? And I recruited some internal folks, and I'm blanking on the guy's name. And afterwards, he told me, like, I almost died because I melted down. I had to lay on the floor afterwards because when you're doing this, if you're a solo host, you have to be Terry Gross, right? You have to listen to the guests, you have to ask good questions,
right.
Listen to their answers. Follow up if needed, because often, especially technical stuff, it's great if you could clarify a little bit or kind of, get rid of the acronyms or kind of give the high level summary that the engineer just gave you, the low level. You got to think of the next question. You got to be ready for the next question. And you had chat going on. So you had to make jokes in the chat room. And that actually, you have to split your brain up into a lot of pieces to actually do that. It turns out it's a kind of you get better at it over time.
You do get better at it, and you start to learn to blend it a little bit, because you're right. A lot of times I catch myself thinking about the next question while the person's answering this question, and I don't even pay attention to the answer because I'm so focused on the next question in my brain. And it takes a little while to get used to having that split brain thing happen while you're looking at your screen, thinking of the next question, and listening and being current. It takes a minute.
It is a performance. You want to say something interesting, right? With energy. It's not like you're whispering to your lover, or you're just having a conversation over coffee and you're both kind of bored violently the day. We're on stage and people are listening, and hopefully it's interactive. I don't know. We used to some of the guests were scheduled far in advance. Sometimes it was last minute. Every week comes around awfully fast, and so sometimes I would just grab a product manager walking down the hallway and say, "Hey, can you be on the show today?" So, and then I did a lot myself, and then we often, I think we pulled in some people from the community as well. There are regulars. I would call on people. Frankly, I would call on people without warning. That's kind of was my usual co-host methodology.
Yeah, that was it. I remember Alex Mayer and the news, right? Mm-hmm. Like, I think that one. And I still get people asking me, are we going to go reach out to Alex Mayer and have her come back and say hello, right? So there's definitely you made a mark on people, and Alex Mayer made a mark on people, right? That
was a good team, yeah, with Alex. Yeah, we tried video. We did news for a while. But we
did do video, and the video actually worked out great until somebody stole all our equipment coming back from Europe, if I remember right. It was a fun time.
Yeah, I really like video. I mean, most of my meetings these days are on Zoom, right? And most of what I do, so you got to comb your hair and shave and stuff. It's not phone anymore. I think video is much more accessible these days. And then, but the news, Eric and Ishmael, there's lots of places to get news. And so the real value add is the connection and the real conversation, I think.
Yeah, you're absolutely right about that. It is, and now because we have live stream, they also tell me, oh, by the way, while you're looking at your chat and you're thinking of the next question and you're listening to the person that's doing a question, don't forget to look at the camera because you're publishing on YouTube, and the YouTubers want to actually look at you and look at the camera so you feel like you're actually addressing them, as opposed to looking down at the screens, keeping track of everything that's going on, which is nearly impossible.
That's right. Good point. I got to make sure I look at the camera.
Every once in a while. Well, that's the thing. Do we really want to do that? You can't be all to everybody. So maybe we'll look at the camera once in a while. Maybe we won't. And with that, what are you guys? Before we let you go, John, or at least you can hang out and be with the podcast, ask questions if you want. But any interesting, cool things? Because I know you're always on that edge, right? You're always out there doing stuff. You do stuff with the Cube sometimes. Is there anything interesting in community that you've seen that you're excited about?
Interesting in community.
Or anything, any space you're looking in these days. Right?
Well, I mean, you said I'm on the edge. I mean, I think edge computing is super interesting, whether that's, distributed remote data sites or all the way down to IoT. I was at KubeCon this year, so obviously lots of Kubernetes stuff going on. multi-cloud, cloud rationalization is really super interesting to me right now. I also dabble in like the no-code things, and I'm getting more into data science. There's really interesting things going on, not with the maybe in a previous life I might have called myself a data scientist, but with the infrastructure required. Somebody's got to set up, all the databases and all the workflows, and care deeply about GPU utilization in the cloud and all this sort of thing. So that infrastructure layer below the data scientist, which I'm not even sure has a name, maybe it's data engineer, I think is fascinating and is an area that is woefully kind of under-organized, or at least if they're organized together, I haven't found the right conferences or blogs or whatever to write about. And Eric, I'm also interested in what I'm about to explore more, and from the community side is like, what is the role of community and blogging and in 2020, right? Do you still start a blog? Do you start a video blog? Do you go to LinkedIn? Do you go to Medium? Do you go to something like dev.to? Do we still have blogs on the VMTN forums? They worked okay. I think there's probably better ways of doing it, but is a blog that you haven't, is a personal blog that you haven't written to in 5 years, is that an appropriate representation of your persona online? I think there's some really interesting stuff about IndieWeb and syndication. I think that's what are the next generation of folks? How are they going to make community? How are they going to connect in a community of practice? And how does that help their career?
And what I'm looking at also in 2020 is, as we move into SaaS services instead of on-prem installation, right? People are consuming software as opposed to installing, configuring, and running the guts of it. Now they're just, you get online and you consume a SaaS service. It's set up for you. It runs on Amazon somewhere. You don't know. You're just using the software. What does community around that mean, right? Do you need community if you're just clicking on stuff at Amazon? And what does that mean? And what are the value props that community offer when you're not talking about how to make things run and how to set up computers and data centers? What's that upper level function that community can offer to consumers that are actually just using software hosted on a SaaS service somewhere?
Mm-hmm. Yeah, how are you innovate if there's not many nerd knobs? How do you get together and innovate and figure stuff out?
Yeah, right. Is there a need for it? And yeah, there is. There's always the next challenge. That's technology, right? It's always moving forward. If it wasn't, it wouldn't be called tech, and we shouldn't probably be in Silicon Valley, the most expensive place in the world to possibly live, if you're not going to be out on the edge doing stuff. So yeah, I'm sure there will be more edge stuff.
It sounds like we're going to bring John back later on this year, have him give us his findings on how communities are,
Yeah, we should, now that we're allowed to use his name again. Apparently now that he's here, it only took another 300 podcasts to make it okay to have John Troyer back on the show, talk about things. John Troyer, thanks a lot for coming in for podcast number 500. You still have me beat because you went 270 some number, 280, whatever, and we're only at 500, so I'm not even.
That's just around the corner. That's blink of an eye. The kids don't even be out of college.
I got to go look and see. I have all the agendas, and I started at 279. So you managed to go up to like 280, and so I still got a few left.
You'll catch them.
I'll catch you. But then you also been doing all the Geek Whisper podcasts, so it isn't like you went away or anything.
Mm-hmm. Yeah, and I produce a podcast called Real Job Talk with my wife Kat and her partner in crime Liz, and I'm actually going to start up a new Zoom one, I think, just me talking to people. So it's all yeah. Go ahead.
Yeah, I had to go to CES. I want to go to CES. My son worked at Roku and invited me to go to CES. But to get a badge, you actually have to show that you're an evangelist or you're something, right? That you have a public persona. And I actually used the interview you did with me on one of your podcasts, right, where you actually wrote it up and put it online and said who I was. And I screenshotted that and submitted that as my CES authentication.
And that worked?
Yeah, it did. Yeah, it did. So I appreciate that. Yeah. So you have been busy. Do you still run Tech Reckoning, or do you do others? Is the brand shifted to now something else?
Tech Reckoning is the company and the brand. I do consulting. I work with a lot of other folks. Ironically, Eric, when I do work in the influencer advocacy space, right, I'm most of the time giving people advice, make your program bigger. because there's a lot of people who just, they have a small program. They like only working with a few people. And I see the opportunity is to grow it. Sure, you have a core of people who are super evangelists, but there's a lot of people who could benefit by the special attention and the networking, and who will help. There's a mutually beneficial relationship. And then, of course, there's that whole, next circle out of people who are, users or interested parties. Anyway, so most of the time, Eric, I'm telling people to make their programs bigger. So I do some work in that, but I'm doing more tech analysis these days too as well. And I try to help marketing people. I try to be the connection between tech and marketing, and I try to keep it interesting.
That's awesome. It's great. Always have a great, strong community of people there. All perspectives are welcome. And John, thanks a lot for spinning it up and teaching me how to do some of this. And I love you and I hate you all at the same time, right? Because I have to do this every once.
Well, the feeling is mutual. Hey, can I stick around? Can I ask a question?
Yeah, sure. Yeah, let's get into our main guest, because I think this is the subject that I find between ARM and Kubernetes. Those are the two this year that I find fun. I have to go back to the vSphere stuff too and enjoy that. But let's talk ARM. So our guest has been patiently waiting. He is. Let's see if I can get his title right here. Andrei Warkentin. He's the co-founder and tech lead on the ESXi ARM project out of the CPBU, which is Cloud Platform Business Unit at VMware. Andrei, welcome to the show. Thanks for being patient, and it's super cool to have you on. Why don't you tell us a little bit about how long you've been at VMware? Tell me a little bit about VMware. How long have you been here, and what are you working on today?
Well, this is my ninth year at VMware. Time does really fly. So I'm a tech lead for the ESXi ARM project. We're having tons of fun, kind of doing the impossible, porting vSphere to 64-bit ARM platforms, which are cutting edge. It's been a wild ride seeing this space firm up just from an idea of a standardized ARM platform definition, ARM servers, and ARM cloud, ARM edge. So it's been pretty neat. Throughout the history of this project, we've had to wear many different hats. So right now we're in the Cloud Platform Business Unit. For those of you who might not know, CPBU is basically the business unit that does vSphere. Prior to that, the project was located in the office of the CTO, which isn't just pure research, but is sort of directional, strategic. And now we have PMs, right? When we were in Okta, we did everything, right? So we were obviously engineers, we were our marketing, or our project and product management. So it was pretty crazy. You get to learn many different things and find out you're not very good at them. So.
All right, that's great. So time does fly, and I hate that it flies because we all get older, but yet I still feel like a kid in a candy store. I get these little ARM CPUs, and I'm having fun with them. Let's talk about the growth of ARM and the CPU business in general. What's the trend here? I know everybody that listens to this podcast build x86 servers and data centers, most of us. And so, the trend, why don't you talk a little bit about the ARM trend in general? How did we get from x86 owning everything to ARM showing up now? I think ARM CPU is the most number of CPUs in the whole world. So why don't you give a little bit of the history of the industry and why VMware thinks this is worth investing in?
So let me try to generalize and kind of sum it up. Right. So we know that pretty much around, say, 2010, 2012, ARM dominated the mobile ecosystem. And very much say disrupted the personal computing business market, right? Everybody had to have a phone, and PCs were kind of going down low. Now, ARM doesn't by itself make any CPUs. They make sort of designs, right? And then somebody else makes the CPUs, makes the chips. And so what ARM initially facilitated is this wild west where you have tons of competition, everybody making their own CPUs, their own system on chips that run these mobile phones. And so on one end, ARM, there's no such thing as an x86 mobile smartphone or anything, right? On the other hand, it was not standardized in any meaningful way. I mean, yes, it all ran Android, right? I mean, there were other operating systems before that, but they all kind of went away. There's all Linux, it's all Android, but at the hardware level, it was not really standardized. So the trend in ARM today is being boring. Now, what does that mean? x86 is boring, and boring is very good. Boring means standardized. ARM has been traditionally a vertically integrated ecosystem. What this means is that usually the same company that produces the physical chip, they also produce the low-level software called the BSP, board support package, to enable to run an operating system on it. And then many, many times this company will be tightly working with, say, a cell phone manufacturer or kind of ODM to design a turnkey solution, right, a whole stack based on this chip and the software. Now, PCs and PC servers is a horizontally integrated ecosystem. That means that the company that designs the CPU is not the same company that designs the motherboard, which is not the same company that built the box, which is not the same company that built the system software, which is not the same company that built the application stack, which is not the same company that sells the stuff. So that's horizontally versus vertical. So ARM is going horizontal, and this started with ARM servers. Now, ARM servers are boring because they look and act just like x86 servers. To sum up how, it means that a proprietary software vendor like Microsoft or VMware can create a single operating system image or hypervisor OS image that can then run on any one of these machines without having to know basically who made it, what's inside. Much to the same degree, all of us were building PCs back in the day. Maybe some of us still do. Remember the little CD-ROM with drivers on them, right? There's a network driver, there's a sound card driver. Well, guess what?
Sure.
You can still install Windows without that. I mean, you don't have anything, right? But you'll have enough to at least go online and install the drivers. So that's boring. Boring is great. Okay. Boring is great. Now this trend is starting with servers, but now it's going onto the smaller devices as well, such as I use an edge compute, I use an infrastructure. So let me fix my sound and is this a little better?
Nope, that got worse.
You were fine earlier.
Yeah, I think Julia was struggling with some sound when she's live streaming, so you can work on it for a second. Yeah, that got worse though, I think.
This is okay?
Yeah.
All right.
Yeah, talk some more. Just All right. So we'll continue on, and she'll play with you. So that's interesting in that ARM has been vertical, x86 has been horizontal, and you're right. All the ARM devices, if you look at it, are all just packaged together, in one unit in a cell phone or in something. Now that we have IoT starting to happen, and the need for, I think ARM brings to the table maybe low power consumption, better power management. Maybe they're smaller chips. I don't know why ARM is used in the smaller footprint, other than it doesn't have the giant x86 Intel footprint to run big servers. So maybe it's just a smaller CPU, uses less power, and the licensing terms might be more favorable. Is that kind of how we transition to now? And then how does that play in the edge, and why is ARM showing up as these small server packages that are box mountable on a wall somewhere in an edge location?
Right. So I would say that the reason why you see ARM flourishing is there's a major reason for it, and then there's an enabling factor. So the main reason is that what you see here is finding the best fit between hardware and workload. Right. So depending on what you want to do, right, especially if you talk about edge compute, what does edge compute mean? Well, it means these systems are running something fairly specialized. So it's not just a general purpose system in a data center somewhere, right? So it's going to run some specific data collection, aggregation, analysis. Now, it has to run that in a certain kind of environment. This environment may be an industrial kind of environment with limits on power, cooling, space, right? But not just for edge. Let's look at cloud, right? Are there limiting factors there as well, right? You can buy different size instances from cloud vendors, but of course, if you're deploying a cloud scale application, at scale clearly, you don't want to buy the biggest instance you can find because it won't be used to full capacity, right? It's always about making sure you're at capacity, that the hardware you pick, the instance you got for edge, for cloud. It doesn't matter what you're doing. You do not want to have excess capacity, right? Now, in the cloud sense, it's easy to understand. Well, you're paying with your money up front, right? And at the edge as well, right? Because you need to have cheap devices. You need them to have to fit within the confines of the environment. The other ARM thing really is that, well, there's much more choice in terms of building customized solutions. So you have many, many more vendors building CPUs, right? And then ODMs on top of that, creating the actual platforms. Also, what I think is fairly important is that, well, I mean, it's true, right? Because ARM initially grew from this kind of embedded mindset. People still take to that, well, you know, if I had to go embedded or smaller, I have to go with ARM. Right? I don't think it's actually true these days, but if you look at the variance of solutions, I mean, yes, there are some really small ARM-based solutions, not solutions that would say work well, you know, that we will not virtualize, but you know, microcontrollers, real-time chips, all these chips, they're different from the same kind of application-grade ARM CPUs you would see in servers, phones, or edge compute, or smart NICs, or cloud instances, but they're still ARM. So there's much more choice. So if you have to basically get your workload requirements, right, and then whittle down the hardware to the smallest, cheapest, coolest running thing you can find, yeah, that's probably going to be ARM. Now, what about the enabling function I was talking about? Well, enabling function is open source. I don't think what's happening right now with ARM servers or ARM Edge or Smart NICs or anything other stuff, I don't think any of this would be happening if it wasn't for open source. I mean, inherently, what operating system or what software stack would I use or would you use to build an IoT application or a cloud-native application? Oh, the Linux, right? So it's Linux plus either open source libraries or open source exactly, right? Or maybe you're building on top of this stuff. You know, you look back 20 years ago, right? You couldn't see any other architectures penetrate, you know, the market, because first of all, there was no real markets. That was the enterprise market. And the enterprise market was, does it run Windows? Does it run Oracle? No, go away, right? And with ARM, obviously, this is it's very different because you know these two kind of new novel ecosystems for building applications. Those run on Linux. Linux runs on ARM. Well, there you go.
There you go. And you're right in the sense that like social channels have actually gone out in the social world that I live in. You know, there are specialty social channels for almost everything now. So we've gone from homogeneous to kind of specialized. And I can see that when you're building solutions, you know, Intel was the ultimate horizontal homogeneous platform. But as you get low license cost hardware, you see specialization starting to happen for solutions, whether it's in your Tesla car or in your mobile phone or in various places. You're actually seeing that specialization where you can build hardware and software put together in a solution, you know, just as you say, low cost, optimized for a particular problem set. And then I think you're right.
There's a word of caution I want to say, right? So basically, vertical ecosystems work, but to a degree, right? I mean, they can work if you're, say, Apple, right? But then many companies think they're Apple, and they're not, right? You know, we've seen vertical ecosystems work for ARM with the Raspberry Pi ecosystem, as in the thing that the Raspberry Pi Foundation does. But it doesn't actually work for anybody. I used to work in the mobile phone business, right? And you know the most commonly asked question about Android phones is? You promised me an update for Android XYZ, and you haven't delivered. What's going on, right? So this is one of those things where you see this happen, and it's not because cell phone manufacturer is bad or good. It's because, well, it's an enormous burden and strain, right? To basically
underestimate the work. Yeah,
exactly.
You underestimate.
Now, visualization is very important, and this is why ARM can shine. But we have to be very careful about like where innovation matters, right? Now, ARM is becoming more homogeneous, but not at the expense of not enabling innovation. What they're saying is, let's standardize the basics, like how an operating system boots, right? How does it expose devices, right? Kind of the same things that, you know, there's no value, right? You got to standardize it, and in fact, you got to do it the same way you do in x86. So, and this has been happening, right? So this is actually one of the reasons why companies like VMware and Microsoft can work on operating systems that run on these ARM-based systems.
Yeah, so let's talk a little bit about ESXi and ARM, and where are we going with this? I know we've talked about doing ESXi on ARM. What's the point of it, and where are we in that process?
Great. So ESXi and ARM. ESXi targets A-profile ARM chips. So, like I said, these are chips, application-grade chips that go. That generally go into mobile phones, servers, edge compute, that kind of thing, right? Now, we're not targeting phones, right? But ESXi does not target the M-profile microcontrollers and does not target R-profile real-time chips. So we target 64-bit chips that are capable of virtualization. First time we were publicly announced was VMworld 2018. That was in Las Vegas, and we presented VMware's vision for edge compute. If you remember, that was the wind turbine demo. And edge compute is one major area where there's potential for ESXi ARM. There are no concrete productization plans just yet, but we're actively working on in this particular line. Another space where you saw ESXi ARM pop up publicly was with the cloud, right? So, for example, VMworld 2019 in Barcelona gave a kind of a State of the Union address on ESXi ARM, and I showed that ESXi ARM can run on Amazon's A1 Metal instances. These are servers that AWS build themselves with their own custom CPU. So yeah, wow, like AWS can build their own ARM chips, right? And the context for that is to explore, if our customers want to adopt ARM-based systems in AWS, right? Well, we have something that leverages AWS too, right? That's our VMC on AWS solution. So clearly, if our customers choose to adopt ARM in EC2, then it might be interesting to bring VMC over to support those instances. And then hot on the heels of that, at reInvent 2019 again in Vegas, I talked about ESXi and A1 and showed ESXi running on Amazon's new M6G cloud instances. Now, while A1 was an experiment that AWS did, it was a low-powered system, good for some workloads and not CPU intensive. M6G is positioned as being 20% cheaper than M5, while up to 40% better on top of that than M5. If you're familiar with AWS nomenclature, M5 is the bread and butter of EC2 instances. So it's built with sort of latest Xeon processors, and it's not compute optimized, it's not RAM optimized or anything optimized, but it's a general purpose box. It's pretty expensive too. It's about $100 a day, I believe, right? So it's pretty amazing when you had Andy Jassy on stage start talking about how customers now don't have to think about what workloads could work on ARM. They can just throw anything at it and save money. So that was pretty interesting. And another place where you saw ESXi ARM pop up was, of course, VMworld 2019 again, but in San Francisco, when our CTO was on stage both of our CTOs were on stage, Ray Farrell and Greg, and they showed ESXi running on SmartNICs, right, running on Mellanox and Broadcom devices. So that's kind of the third place where you saw ESXi ARM being demonstrated.
Wow. Yeah, that makes sense, the cloud space. John Troyer, what do you think of all this? You're just watching this now. This is a transition that's happening in our industry.
Oh, yeah. I mean, you clearly see it. It's early on, like we said, it's early on the cloud and server side. It's here. It's been coming for a while. In the chat, we were talking about, the whole IoT side, which is a whole other thing. It's clearly here. It's clearly people are going to be able to take advantage of it. Architecture, whatever your architectures are, a lot of us are beholden to, our software providers. But it's great that it's an option now. And clearly CPU. I mean, this has been every 10 years we say this, right? That CPU is no longer the limiting factor in our applications. We got plenty of compute for whatever we want to do. It's the rest of it. Hey, Andrei, I'm actually kind of curious. How hard was it to port the kernel or to make an equivalent kernel on ARM. And I mean, most of us here are kind of operator level folks, but we are computer science adjacent, many of us. And so, like, I mean, we all heard the story about how x86 was card and you had to bring zero stuff, and it wasn't really designed for that. And, over the years, and Intel added, instructions, and, people who've been following and kind of understand how the magic happens down there, kind of low-level stuff. I mean, was it hard? Was it hard, and was it surprisingly hard or easy? Or what was the experience like in pulling it all over, the kernel functionality over to ARM?
I think that's a great question. So first of all, it is the same code base, right? So the same code base can be built today on ARM and for x86. Now, what is the impedance mismatch between basically an operating system initially written for x86 and a 64-bit ARM chip? Not as much as you maybe expect, right? And part of the reason for that, I would say the general shape, right, is the same, right? And there's a good reason for that. When ARM designed the 64-bit architecture, 64-bit ARM architecture, they didn't design it in the vacuum. So not only did they consult with engineers from VMware, from Microsoft, I'm sure from other places, but they made sure that when they made design decisions around how, say, CPU virtualization would work, or how a memory management unit would work, all these things, they're generally operating the same way, right? Now, of course, when you look at page tables used by a memory management unit, it's the same sort of inverted tree layout. Now, the bits are in different places and have different meanings, but that can be all abstracted away in the source code. Conceptually, if we lived in an alternate reality where we had to port ESXi to, say, Power 8 or anything earlier than that, IBM Power 8, that would be pretty challenging, simply because a Power 8 chip does look very different from an x86 or 64-bit ARM chip. But even in that space, Power 9, you see this convergence, right, where ARM and x86 and Power, they have basically the same functionality, right? I mean, they're roughly in the same kind of performance and power ballpark, right? And you're not comparing mainframes to microcontrollers anymore. So that's kind of interesting, right? And I mean, this is all on purpose, right? Because if you make it too difficult for operating system vendors to go and make your stuff work, well, they might not, right? And then two, it'll be on this weird beaten path. It's not going to be the same code that's exercised by everybody else. But you said something very insightful. You said that nobody really the CPUs, the actual CPU itself doesn't matter. You have enough compute, but it's another interesting function there. Nobody ever takes a workload and says, I'm going to write an application for an AMD Ryzen. Nobody does that, right? I mean, you might choose to optimize an application with the features on your CPU, but what you have is, well, I have my list of requirements, and maybe I have a choice for an environment. Well, again, that environment today is Linux, right? So Linux is the common platform, right? And then Linux runs on ARM and x86 and some other things. So, yeah. But anyway, I think you're asking about difficulties, and
Andrei,
talk about difficulties. Yeah.
So, Andrei, I suppose the caveat to that is if you're in kind of disconnected low power, right? Because then CPU may be coming up, because more power, you can run the CPU at full speed. You're off power, you may want to slow it down. But with that caveat, sorry, I cut. Please, that sounds like you're getting to the juicy part.
I would say, well, again, from a technical perspective, I don't think there's any challenges, but whenever you talk about porting software, a lot of it is not particularly sexy work, right? It's mostly pruning the branches and kind of sweeping stuff around, getting code to compile, right? And then you realize it depends on this library, and this library is, you got to clean up the build systems for different components. And then when we started, many things in the ecosystem weren't quite yet perfectly well tested or imported to ARM, and so we did a lot of this work ourselves. And so I would say right now, for example, right, if VMware decided to go and ever port ESXi to, say, RISC-V or something, right? I mean, that would be a much cheaper, simpler proposition than it was originally to port it to ARM, right? There's a lot of sort of background work that doesn't have anything to do with sort of well, I got to come up with a novel, solution for a problem, how to make this specific functionality work. So technically, I think it's actually pretty fine. I mean, of course, there are differences. Right? I'm not saying that an ARM system today is basically an x86 clone, but they definitely, I mean, at the CPU level, definitely try to make sure it's not too difficult. And again, at the system level, there's this whole ecosystem called the ARM server-ready ecosystem, and there are two specifications: the server-based system architecture, that's a hardware spec, and the server-based booting requirements, that's the firmware spec, that basically say it has to look like an x86 server, it has to boot like EFI and ACPI like an x86 server, because it can be weird. If it's too weird for OSVs, OS vendors, if it's too weird for ODMs, if it's too weird for operators or application developers, it's not going to be adopted. Now, you might have hear a lot of server in there, right? That's where this dynamic started. Good news is it is coming to the edge, and we can talk about why that's interesting.
All right, interesting. All right, great question, John. We have a couple other things to get to, so I want to move on with that. So I think the point we made when we're talking about why VMware's here, the cloud model, I think, is going to drive some of this. The Linux model is going to drive some of this. The microservices architecture, where small CPUs, a large number of lots of units, would also drive this. But I actually see, if Amazon's offering it and we have VMC on AWS where you can just move your workload over, we want to capture new workloads, it makes sense that, that somebody put out a really good article on Kubernetes the other day and talked about why you want to put it in a VM, right? Even your microservices in a VM. And if you're running those microservices and you have all the advantages of a VM to run your Kubernetes microservices hosted apps there, then it would make sense that we put that whole stack on ARM, because Amazon's offering up ARM platforms, and customers are actually going to be there doing that as well. So I think that's my summation of why VMware cares about this space, because customers are starting to build workloads and running them on Linux, and there's an opportunity.
Really going to sum it up, I would say the reason why VMware cares about ARM is specifically around new workloads, right? So greenfield, right? I can tell you what we don't care about. We don't really care about the ARM in the enterprise. I mean, frankly, that doesn't actually exist, right? And I'll tell you, it won't actually exist until Microsoft puts out, say, a server build of Windows out, and people actually start adopting it in data centers. But there's no real reason to do that, right? That's not the battlefield, effectively, right? In enterprise today is basically legacy. Now, don't confuse enterprise and on-prem. Those are actually two different things, right? You can be deploying kind of modern applications, all native scale, right? And sometimes you have to be on-prem due to many other factors why you can be in cloud, right? But so we don't care about enterprise. We care about new workloads. So edge compute is, I think, on the verge of an explosion, right? And ARM is not going to be the only player in space. It isn't today, but it will be. Now, edge is actually kind of three different things that I see. So there's a thing that you folks mentioned, IoT, right? ARM calls it the far edge, okay? So small devices, really low power, right? Then there's what ARM calls near edge. So those far edge devices are factories, oil rigs, they could be really doing kind of data collection aggregation, IoT gateways, if I may. Then there's the concept of near edge. Near edge are fairly boring service systems, although they may be in novel, smaller footprints like Open19. These are systems sitting by base stations, telco towers. What are they doing? Well, they're either running parts of the telco stack, right, or they're there to be basically sold as a kind of geo-located cloud, right? Imagine you're broadcasting a game, and of course you want to stream everything in 8K. Well, guess what, right? You don't want to do the encoding in the cloud. You want to do the encoding as close to the stadium as possible. So you're going to go to, I don't know, some provider like Verizon or Sprint or AT&T, and maybe they'll sell you some capacity where you go and run your encoders. And they'll be in a small podlet or data center let by a base station. So there's a company called Packet, for example, that's kind of their business model, right? So Packet's model is these little edgelets, as I would call them. And then, of course, there's this interesting new space with things like SmartNICs, right? A SmartNIC is really a microserver on a PCI card. I mean, it's a NIC, right? But it's also smart. I mean, what does that even mean, right? I mean, yeah, of course, you could, if you put on your telco hat, right, you could be running some network function virtualization things on there, right? Okay, that's kind of interesting, maybe, right? But if you put on your like CSP hat, or maybe even your kind of your typical enterprise customer hat, you could be using this as an off-the-shelf building block to improve to servers, to disaggregate them, right? To offload some functionality from host CPUs to these kind of accelerators. So this could be an accelerator to make vSphere go fast, right? Kind of much in the same way where, for example, Amazon has the Nitro architecture, right? That they offload network and storage virtualization, right? Why do they do that? Because they want to sell host CPU cycles to the customer, right? But all customers are the same, right? They all want to make good use of the CPU they're paying for. They like all the features that companies like VMware, Microsoft, cloud providers provide, but not at the expense, of course, of the underlying hardware. So that's kind of another battlefield right there. I would say it's edge, right? Now, another thing that's clearly edge is edge network function virtualization. Everybody has a Wi-Fi router at home, right? Of course. Or some kind of network firewall or like a network switch. But there are these boxes you can go get, or maybe your telco will send them to you. They look like a bit of infrastructure, but they will have 16 gigs of RAM in there. They'll have like 8 cores. They'll have NVMe or SATA in them. And they will actually use virtualization containers to partition up the different telco workloads. So that's network function virtualization at the edge to build something called universal customer premise equipment. Customer premise equipment is because it's to the premises of the customer. So that's edge too. And telco is another big area VMware, of course, is playing and is kind of wants to put more and more effort into. I know that's a lot of info. I'm sorry.
No, but that's great. That's great answers, and takes us into
greenfield. Yeah.
Sure. Yep. Yeah. Greenfield apps, right? And that makes sense. A lot of places there, and it's an exploding market. Next thing we want to cover is. It's funny, I'll just take an aside here and go that every quarter we roll up our numbers and we have to report them up to our CMO and talk about, growth of how many conversations in social and community and all that. And this year we were actually 12 or 15% down year over year. And I had to explain, do we have a problem? Our traffic is down. Why are we down? Down is never good in the corporate world. But what we looked at was last year Pat Gelsinger in Q4 was on stage in Barcelona, and he held up a Raspberry Pi, and he went, yes, you can run ESXi, even on this little guy, and that trended. We got like 4 million downloads of that video. We got tons of traffic. Social traffic was through the roof. Between that and we acquired Heptios, Kubernetes. So those two events happened and drove our traffic so high that this year our traffic was down by 12%, even though we were trending up across year-long trends because of that Raspberry Pi Pat Gelsinger thing. So I got to come back to Raspberry Pi, ESXi. We talked about it. We did some kind of prototype demos. And I know that we'll do a shout out. We're going to have a big launch March 10th. So go look for a sign up for our March 10th launch event. I can't talk about what we're announcing other than maybe possibly vSphere and what we're going to do in 2020 around vSphere, maybe a new release that you'll be in heaven if you hear about it. So vSphere Heaven, that's what I'm gonna call it. So that go out and sign up for vSphere Heaven launch that's going to be happening. And then at the same time, ESXi Raspberry Pi 4. The 4 comes out. It's got 4 gig on it. What's the story with ever getting to put a ESXi on a Raspberry for a home lab?
So my first question is, do we have time to talk about like how that Pi 3 demo happened? I mean, it's a pretty cool story.
We got 15 minutes left with the podcast, so you're good.
I think you're gonna love the story. That is actually the most unlikely demo that has ever happened, right? So it started at VMworld 2018 in Las Vegas, and we had that announcement on stage, of course, with Pat and Ray and the wind turbines, and I was manning the very kind of opaquely named booth, Octo booth that was around Edge Compute. It was actually the ARM booth, right? Effectively, it's the only thing we showed.
Right, I remember the ARM.
And so we're actually showing there a bunch of ARM platforms and talking about what we have there with ESXi and how awesome it is. And all these people approach me and ask me, Andrei, like, maybe I can't get it, but does it run on the Raspberry Pi 3? And I am patiently standing there explaining to them why it technically cannot happen, right? It doesn't have enough RAM, it's weird, and, it's actually a pretty weird platform, like even from the perspective of sort of your, vertically integrated ecosystem, for the traditional vertically integrated ARM ecosystem. And so when I left that show, I was like, well, for all these people who are really disappointed by me telling them no about the Pi 3, maybe I should actually try and prove myself wrong. This was really an exercise in basically proving that, I know what I'm talking about, and yes, it's impossible. So the short answer is yes, Pi 3 was actually impossible, but for a bunch of interesting contortions and hacks, we got ESXi running on the Pi 3. Now, we were kind of approaching the dates for the event in Barcelona, and I kind of shopped around the ideas of, hey, so we have this, ESXi running on the Pi 3. I think it could be pretty cool to show, just because there's I had a lot of outreach around ESXi on the Pi 3. It's like people were like, I don't know, Andrei, it's a little late, okay. And then I heard that Pat Gelsinger was going to visit one of the Massachusetts offices. All right? So I worked in the Boston office, and he was visiting for a fireside chat, the Burlington, Massachusetts office, because he was really there for a customer meeting. So, we had a colleague visiting us from Cork, Ireland. His name is Andreas Scher. He was actually doing a tape rig getting DSAN up and running on ARM. So I grabbed him and said, Andreas, you want to go see our other office in Burlington? He's like, well, sure, Andrei, why not? So we took the Raspberry Pi 3 and we drove straight to Burlington. And basically, I was like, okay, I got to just grab 3 minutes of Pat's time. And we did actually arrange this like the day before. I was talking to the site directors of there, like, oh, can we do this?
Grab a couple.
Yep. Exactly, right. And so that was this fireside chat, and I was just sitting there kind of really patiently waiting for the thing to end. And then as I was kind of approach Pat, there was some sales people like, oh, no, sorry, no time, we got to leave. And so one of the facilities folks from Boston that was there in the Burlington office as well, he just kept waving at me. So just go. And I'm like, I don't know what I'm doing. So, and I just started walking, and he told me, just go into the room where you did all the setup, right? And so I did. And this is the most amazing thing ever. So the salespeople were leading Pat out of the office. The guy just extends his hand, says, oh, Pat, this way, please. So Pat just, goes into the room, and we do our 3-minute spiel. And he's like, well, I think this is really cool. And that's how the demo was on basically on stage.
Nice. That was.
I'm a little flustered right now, so for whatever reason, just the name evaded me. But I'll give it to you in a sec, because this gentleman sort of really kind of it's amazing, right?
Right.
Exactly, right. Would I be able to do something like that? Yeah, myself, I don't know.
Some of that stuff got out on blogs, and and then there have been. So then the year after this, it was out. People, Pat mentioned it. A couple of us eager people like myself and William Lamb got a hold of the version, because I think you gave it to us to be nice, right? And then we kind of demoed it here or there, but we never gave it out, right? But then it became this kind of thing that's there that nobody's ever going to be able to get, right? Like, because 1 gig of memory on a Raspberry Pi, it's not very much memory to do anything anyway, right? So it was a party trick. Anything.
Well, it's actually pretty cool, right? So the gentleman's name is Matt Holland. So thanks a lot, Matt. You're the best. And if I could do something like that for somebody else, I think I would just love to repay the favor in that way. Now, what we actually had is pretty amazing, because we could run on a single 1 gig Pi like a real VM, right? And another party trick, I ran a small Linux VM with a DOS emulator, QBasic, and you could actually DNC into it and play Snake. Okay, so Pi 3 is cool as a gimmick, right? It's not really like a product or any way. No, but then the Pi 4 came around. And the Pi 4 came out with 4 gigs of RAM. and more importantly, the Pi 4 is much more standardized from a hardware perspective. And this actually brings basically the whole new the whole Pi 4 effort brings. I would say this is not even a VMware story. This is an ARM ecosystem story. I think it opens up a new whole chapter where you're going to see massive standardization of ARM edge compute. So I can tell you right now, with the Pi 4, we have a joint project in VMware and ARM to develop firmware for the Raspberry Pi 4 that will give the same kind of ARM server-ready experience. Like, this means that, well, traditionally on a Raspberry Pi, you only can run, an operating system that's made for the Raspberry Pi, right? You will be able to run any system any operating system that complies to these server-ready specs. Well, ESXi is one of these systems, right? So, and I think it would be kind of really fascinating because do you know how much the Raspberry Pi 4 costs?
Yeah, it's like $80 or something pretty cheap.
Nah,
right?
it's 55. It's 55.
55 now. Wow, that's crazy.
For the 4 gig, 35 for the 1 gig.
4 gig.
55, yeah. So $55 actually gives you not a low-end system, right? It uses a Cortex A72 chip, so A72 CPU in that. It's the same kind you can find in A1 Metal AWS server. It's the same kind of chip we highlighted in the bigger Makedon edge compute box used for that wind turbine demo we did. So it's actually like a medium grade. It's not a server grade chip, but it's kind of closely approaching that.
Right.
DDR4 RAM, USB 3, and it has onboard gigabit networking. I mean, I think it's a pretty sweet package.
Yeah, it is a very nice. We got them. We had them at VMworld. They're a very nice 4-core, 2.6 gigahertz, heavy duty. Yeah, like you say, gigabit Ethernet on the boards. They were actually hard to get a hold of when they were sold out, but I think now they've stopped manufacturing. So these things are sweet, nice, yeah. And dual head. If you want to use them as a little engineering workstation, you can. They have dual HDMI outs now as well. So sweet little board.
Another great story. I remember William Lamb sending me a message on Slack Monday. Andre, did you get a Pi 4? I'm like, which Pi 4? And I guess I don't know what I was doing in the weekend, but I wasn't paying any attention. I'm like, William, you mean the April 1st joke? Or no, this is a real Pi 4. I'm like, oh. And then I realized that my colleagues well, order these things. And I'm like, well, I can't even get the 4 gig one apparently because they're all sold out. But then, so in Boston, there's a store called the Micro Center, right? And they ran some kind of deal where if you show up in person on Friday at 10 a.m. or something, you can go buy one, right? And actually, another colleague of mine sent this to me. And I showed up on Friday, and there was a line of people out the door. I'm like, are you guys all here for Pi 4? Yes. I'm like, okay, good. So we all ran into the store and got in, and I left. And when I went back to the office, and I asked, how come you didn't get your Pi 4? It's like, well, I went on the website last night, and the deal was gone. I'm like, whoops, well, I didn't go on the website. I didn't know that the deal was supposed to be canceled, so I got my Pi 4. Anyway, I know people probably don't want to listen to me talk about this random anecdotal stuff. What they really like to hear is what's going on with ESXi and Pi 4. Right, so I think we all understand how valuable a fling could be, right? I can't really comment on any dates or any timeline, but we definitely see value for engaging with the community on that kind of a level. And if there is a fling, which I can't really comment about, and I can't comment on what it could come if there is a fling, but the Pi 4 is clearly the kind of device that if you want to make a fling happen, you got to make it happen in that kind of device. Why? Because anybody can buy it anywhere in the world, high volume, low cost, right? And then you can actually do a lot of pretty cool things in it. So it's not crippled in the same sense that a lot of the smaller boards are. And the work that we're doing with ARM around making this Raspberry Pi 4 kind of a standards first platform does really feed into that a lot. And this actually opens up other interesting things, right? So we're working with, for example, NXP. NXP has this whole line of sit-down-chip CPUs called Layerscape, and Layerscape is kind of a traditional network-oriented chip. It goes into routers and switches. And again, collaboration to bring standardized firmware to that, right? And there's systems, again, that are not as cheap as a Raspberry Pi 4. I mean, a bit more powerful, but in the $300, $500 range, that again I think would be well suited, for a community evaluation such as an ESXi ARM Fling, which I can't really comment on about. Although it's a great idea. I mean, I think it's an idea that's definitely ripe for its existence. And
so I'll jump in here right now, just for people who are listening, because I know that you can't comment on any of that, Andrei. So I'll just, as a community guy, speculate that once the new release of vSphere comes out, right, and let's say that there was going to be a Fling, not saying there is, but let's say there was going to be a Fling, we would probably have to wait for a new vSphere to come out, because let's say the Fling was going to be based on that new version of vSphere. Then I would assume that if we do have a March announcement where we're going to be talking about new vSphere, that if there was going to be a Fling based on that new vSphere, it would be after the announcement of said new vSphere, that then maybe we would possibly see a Fling come out that would allow you to run on a Raspberry Pi 4 with 4 gig of memory. Not that you're saying that, but I'm just saying as a community guy, speculating that might be where we're headed.
Very subtle, Eric.
Very subtle.
I'm saying that it's yeah, I mean, it's not preposterous, right? It's not completely. But I'll tell you what. I mean, the work that we're doing with ARM, with the community around stretching these quote unquote server specs down to edge. I think you can see a lot more other very interesting platforms happening. The one platform I would love to see happen is like NVIDIA Tegra Xavier, Tegra X2, Tegra X1. Because that device with the compute and the GPU, that would be so cool. You know how many people we have asking for Tegras? People doing robot stuff, or even some edge compute gateways. They're using Tegra chips. That's another one, right? That's a huge milestone. So I mean, yeah.
So Ishmail and I were talking about the current Raspberry Pis are at what now? 4 gig.
Yeah. Andrei, what happens when we get to like 16?
And how many years before we get to 16? Like it's like if we're at 4 gig now, and Moore's law is every 2 years, and we're still kind of going on that. Maybe by 2 years from now there'll be a Raspberry Pi 5 that's going to be 8 gig, and then 2 years after that. So 4 years from now we're at 16 gig. Now you've got and double the CPU performance. Now you got really a $50 board that's going to be a real server. Right, like pretty soon.
Well, I mean, conceptually, if you want systems, we have systems. ARM is very varied. Like we have systems. ESXi today runs on systems as low end as 4 gigs of RAM, Cortex-A53, and as high end as 256 threads, 512 gigs of RAM, and just like high end systems, right? So if you really want a system with, say, 16 gigs of RAM today, right, you can go do it. Now, I can tell you that what I'd love to see happen is to see a Raspberry Pi-like device in that price range with ECC RAM, right? Because if you want to run edge compute, like actually not as a toy somewhere, you really want to have ECC. You know why? They can detect failure, right? Because you don't want a thing to be just randomly miscomputing something. Maybe it will crash. That's good, because at least you can detect crashes. But maybe it'll just be churning out bad data, which is just not good anymore. Actually, I love the Pi 4 because with these kind of small board computer systems, one of the arguments, for example, against Pis being deployed, and by the way, Pis are being deployed by real businesses around the world, is that you cannot get a Pi with a support contract. And I know I lost my speech for a few minutes, and then I kind of recovered, and I asked, what would you want somebody to do if they had a support contract for the Pi? Do you expect somebody to show up with a soldering iron and solder on a $50 device? Go buy 3 more, stock up on them. If it dies, throw it away. Replace it, right? You get this. It really is the word I'm looking for. It's it's easily replaceable, right? It's commodity, right? It's basically
like that serverless computer model where you just drop them in, drop a new one in, put in over provision 50 of them, and then if they go bad, just turn them off and keep going.
Well, it's serverless, but we all know where it runs, right?
Right, exactly. Andrei, we're almost at the top of the hour. We're at the top of the hour now, and we're going to have to end it up. But what I always ask the guests when we talk is, where can people follow along, join? Do you guys have a blog? How is it the vSphere blog? How do they follow you, and how do they follow the topic as you move forward?
Great. No, that's a great. So this podcast ran just a few weeks later. We're actually working on getting like an actual blog space, and it's going to be a top-level blog space under the blog space at the VMware site. So
yeah, blog.vmware top. We're setting one up for you. Yeah, that's true. We are.
Yeah.
Yep.
So that's space number one. Space number two, I have a Twitter account that is my unofficial soapbox. All things ARM and all things virtualization ARM, and then if there's anything VMware vSphere related, it's going to be there, right? And if I put something in the chat, will people see it? No.
Great.
Will they?
Yep.
If I put something in the chat, will
they? Yeah.
Okay.
The chat is saved on the podcast, so anybody that's listening to this can go to vmw.re/pod. And do it, but yeah, not the Zoom chat. You'd actually have to be on the TalkShoe chat.
So I pasted it in the Zoom chat, but maybe you can paste that into the everybody chat as well. Another cool thing. So I just set up a web page specifically to talk about the Raspberry Pi 4 EFI work. That's the work that VMware and ARM started, but it's actually community effort, and updates around that will be on that side as well. But the VMware blog will be the premier spot, of course, once we all finish setting it up.
Getting ready. Yep, we'll announce the blog, and we'll definitely come back on the podcast, talk about it. We'll tweet it out as well. Do you have a Twitter handle?
I did. So I pasted that. I keep pasting VMware Guest instead of ever.
What is it? What is the Twitter handle? We'll just do it for people listening in their car.
It's what ain't inside. It's what ain't inside. WHAT.
What ain't inside?
Yeah.
Got it.
So it's WHATAINTINSID. It's what ain't inside. Intel ain't inside. I mean that's what it is, right?
Yeah.
That's what's not inside. That's one of those things. Another cool area. This is kind of ARM, not necessarily VMware specific, but there's a Discord server which is called like the developer ecosystem. There's a channel, so it's linked off that RPi 4 EFI dev thing, but I can provide. I'll paste. Should be able to paste a link here somewhere. Right. Okay, I'll paste it right now. Oops, there it is. I'll paste this Discord invites thing. There's a bunch of channels there. I have one for RPi 4 EFI. Again, it's not for ESXi on the Raspberry Pi 4, but it's for that prerequisite to get ESXi on the Pi 4. And by the way, we've shown ESXi on the Pi 4. We've shown it at the ARM TechCon event, which is ARM's customer event, the main one they run every year in the fall. As part of the infrastructure zone, VMware had a booth there. It was pretty cool. Also showed this at VMware Barcelona, where ARM had a booth on the expo, and we were flooded. Oh man! So even given our location, all that, we had like 500 people in 3 days.
All right, we got to end up. So I'm gonna say thank you, and we will be sending out the blog when it announces. Andrei Warkentin, thank you for doing all the work that you do and making it possible. Very excited about it. Thanks for creating, the founding the ARM practice at VMware. It's going to be a lot of fun. And thanks for coming on the podcast. Can't wait to get an update, and I'm sure we'll see you at VMworld as well. Thanks a lot for joining us.
Thanks for having me.
Yeah, great. John Troyer, are you still around? I don't know if you are. Thank you again if you are. Yep.
Thanks for having me. It was great.
Yeah. Thanks for being here at number 5. Yeah, great topic. And then Tony Foster will do the very last barbecue report. I have one tidbit of barbecue that Amy Lewis did, some barbecue. I saw her on Twitter, and I chatted with her on what she made. I don't know if you got anything interesting. Did you use your new barbecue yet? Are you going to be out in the snow?
I did, yes.
What did you make?
So I made it especially for Podcast 500. I did a smoked meatloaf, and it's absolutely phenomenal.
Wow. So you make up the meatloaf mix, I assume. Do you cook the whole thing in the barbecue from start to finish, or do you cook it in the oven and take it in and smoke it? How does that work?
So I mix it up like standard, only this time I actually used a stuffing mix instead of breadcrumbs or crackers. Used a stuffing mix in there. Mixed it up, put it in a tray with open sides, and put it in and did it low and slow for, 240 for about 3 hours, and it came out awesome.
Very nice. Very nice. All right. Barbecued meatloaf. That sounds like you're cooking
smoked meatloaf.
Smoked meatloaf. Sounds like you're cooking a rock band guy, right? Like from the Rocky Horror Picture Show. Smoked barbecued meatloaf. Love it, Tony Foster. Awesome. That's worthy of podcast number 500. Amy Lewis did a barbecue where she got convinced that it was a half sunny day somewhere she lives in, I think back on the East Coast, and she tweeted out, and it was pouring rain, right? Like, and it started raining midway through barbecue, and she kept going. Oh, no. And I think she did some fish and asparagus. But you know what? Tony Foster, you barbecue in the winter when it's snowing. Amy Lewis back on the East, she barbecues when it's going to be raining. There's never a bad time to get out there and make some yummy barbecue and enjoy it. So
the weather can't hold you back.
Can't hold us back. All right, that's it for this show. Thanks a lot, everybody, for being here. Number 500. Super excited to make it to 1,000. That would be about 10 more years. So that's what I would say. We've been going at it for 10 years. And as long as it's simple and easy to do and we bring community together, we will be there. And, hey, we're YouTube streaming, so don't forget to subscribe. Hit the red subscribe button and click the bell for notifications, and you will get notified when we live stream every week. So until next week, have some good barbecue and have a great rest of your week. Talk to you again.